Hello there. Welcome to this channel. My name is Dick van Oeveren, and in this fourth video of this video series, I will demonstrate how to build a data center from scratch. And in this video, in this particular video, it's all about creating the underlay. It's the Ospf underlay, and on top of that, we create the BGP control plane, and then we will be using the BGP control plane to create that EVPN VXLAN control plane using MPBGP. So in order to do that, in order to create that EVPN VXLAN, we need to have this control plane established. So um, so what I'll do first is create the underlay, the Ospf underlay. What I need for that is, so what we'll be doing is that AFC will provision loopback IP addresses to all the switches. You can see here the loopback 0 interfaces, and then we can use those loopback 0 IP addresses to build the BGP autonomous system and to create the peering relationships based on BGP. But we'll start with OSPF. We will be creating OSPF in the default VRF. So what we do is we go into the routing section, go to VRF, into the default VRF, and then we have this option called underlays. There's no underlay yet, so what we'll do is we'll create a underlay. Let's give it a name. The underlay type would be OSPF. And so we've got some settings here. One of the settings that we need to enter is the transit VLAN. The transit VLAN is really used for VSX. And that is basically, in a VSX, you have the situation where you have a dual control plane. Each VSX switch has its own control plane, which means that if there would be a link failure of one of the VSXs, traffic needs to be redirected through the interswitch link, through the VSX link. And we need to have a transit VLAN to establish that peering between those two VSX switches. And we're using transit VLAN 1299 for this in this case. So so this is some optional router LSA information that you can set. No worry about that. We can just leave them at the default settings. And so that's really it for the OSPF. Now what this will do is we'll create a lot of OSPF configurations on the switches. And so let me take one of the switches here and do a show running OSPF. So you can see that there's no OSPF configuration on this switch. So this is the 8360. Now let me apply that configuration. Go back to that switch. See if it's already there. Yeah, so it's already provisioning OSPF to the interfaces. You can see the OSPF process here using a single area. You can see that one of the IP addresses is being used as router ID, so that's 123. And so you can also see that OSPF is applied to the physical interfaces, and it should also be applied to the loopback interface actually. That's here. Okay. So that's really the underlay configuration. And one of the other things that we can check out once the underlay is created is the routing table. So if we go to IP route tables, you can already see that there are some OSPF entries here. I can select OSPF and run the query, and you can see that there are all kinds of OSPF routes being learned. And I can filter, I can use different filters to check out the different OSPF routes. That's also a cool feature. And so that's the underlay. Next is creating the overlay. It's the BGP overlay that we will be using for EVPN VXLAN. And that's configured using the overlay option here. So you're in the default VRF. You get all these options here, IP interfaces, networks, underlays, and also overlays. And let's create the overlay. It's going to be an iBGP overlay. So let's give it a name again. So we're using iBGP here. We've got some iBGP settings. Let's set the autonomous system number. And the other thing, typically in a leaf spine configuration, you would start to use root reflectors, spine switches as root reflectors, because root reflectors are a really good help to avoid the setup of a full mesh BGP fabric. In this scenario, the 8325 spine switches will act as root reflectors, which means that the leaf switches only have to peer with the spine switches. Okay, next. And so we've got the address pool assignment here again for, for various settings that BGP is using, and some authentication stuff here, which we'll leave. So you can set optional authentication if you want. Go to next. And so this will create the overlay. And before I create the overlay, just go back to the switch and do a show running BGP. See that there's no BGP configuration here. And so let's apply the configuration, and BGP now is provisioned to all the switches in the fabric. Let's go back, do a show run BGP, and you can see that that configuration is there now. Router ID, the neighbors are set. And so this is a leaf switch, right? So this is not a root reflector, but just a plain switch that is establishing the peering with the 26 and 28. And 26 and 28, these are the spine switches. One of the things that we can check out once the overlay is created is, I want to see whether all the neighbors have been established. And what I can do then is I can navigate to the BGP section. I can do that here as well. BGP, or, just do it here, or in the BGP section here. And what I can do then is on the three dots, I click on neighbor summary. And then I can get an overview of all the neighbors. And you can see that they are all in established state. So we should be good to go with the BGP overlay as well. Okay, so next is configuring a VRF. So we're going to use this VRF, this separate VRF for the EVPN VXLAN overlay. Again, we can navigate to the VRFs through this routing option, but I can also see this VRF option here. There are two VRFs. There is the default VRF and the management VRF. So these cannot be changed or removed. These are system defaults. And what I'll do now is I will add a VRF. Let's call it, give it a name. Obviously, that's the name of the VRF, cannot have any spaces. And so, so what I will do is I will apply the VRF to the entire fabric. I don't have to. I can also apply the fabric to selective switches. But in this case, I'll just apply it to all the switches in the fabric. The layer 3 VNI is the layer 3 VNI that we will be using for the symmetric routing, right? So in an overlay, we can also do routing in EVPN VXLAN, and so that routing instance, that layer 3 VNI, requires an ID as well. I'll just give this a number. And yeah, and we also, for the VRFs, we also need to set root targets. And so I'm gonna set a root target mode for both, and I need to create an address family for EVPN. I can also do it for IPv4, IPv6, but for EVPN VXLAN, I need to create an EVPN address family. Okay, and the other thing I need to do is to set a community, an extended community. Okay, let's do 65001 1200 and add that. Okay, and then we get that summary here. You can see the summary, and then so if we're happy with the settings, I'll just click apply. The VRF is created. It is pushed to all the switches in the fabric. And so this means that once it's pushed, let me just do a show running here. You should actually see the VRF being created here. So that's there. And so we can use this VRF to and also here in BGP, obviously we have this layer 2 VPN EVPN address family now. So this will allow BGP to exchange EVPN information between the switches. And the last configuration step in this video is to configure connectivity to the outside world. Remember, in the previous video, I have created a VLAN 1200 on the 8360 that connects through a link aggregation to an 8320 connecting to the outside world. The 8320 is configured for Ospf, and so what I'm going to do is configure the Ospf, configure an SVI on the 8360 for VLAN 1200 so that I have IP connectivity, and I configure Ospf on that switch so that Ospf routing information is exchanged. The 8320 is providing a default route to the internet to the rest of the fabric. So that's that's already provisioned. So I only need to work on that 8360. The first step in getting that working is to create a IP interface. So I go into the IP interface section of this VRF that I've just created. And so let me just add an IP interface for an SVI for VLAN, so for VLAN, which is 1200, VLAN 1200. I'm going to create this SVI on the 8360. The IP subnet is 10.6.200.0/25, so that's a given. That's something that has been configured on the 8320. And the IP address that I will be using on the 8360 is 10.6.200.2. I don't need to do anything about the active gateway. So that's typically something that you would use in an EVPN VXLAN or in a VSX, but not going to use that for now. And the next is providing a name, IP interface to 8320. Click on the summary. Before I do that, let me just go to that 8360. Show VLAN 1200. That's there, but I don't have show running interface VLAN 1200. Doesn't exist. Now let me apply and see if that VLAN exists now. Yes, so you can see that it exists and it is attached to the VRF. It has an IP address. The only thing is that Ospf has not been enabled on this interface yet. And that's what we're going to do next. That's to enable and configure Ospf, but we're going to do that in AFC. Need to do a couple of things here to get OSPF running on this SVI. First, we have to enable OSPF on the VRF. So we go into the OSPF section here, select the VRF, edit, enable OSPF. What we can also do is redistribute the connected and local routes if you want. There's some other settings that you can set, but this basically, the most important one is to enable OSPF globally on the VRF and then click apply. Okay, so that enables OSPF, but we also need to enable OSPF on the switches and on the interfaces. Okay, next is from this GVA VRF, I can click on the three dots and then click on routers. And you can see that there's no router information here. So there are no switches configured for OSPF for this VRF. And so what I can do here now is I can add a router, say 8360. Click next. Select that 8360, of course. Click next. Enable OSPF. I can provide a process ID, so let's do 10 instead of 1, which makes it easier to troubleshoot if there's something not going quite good. Redistribute routes, so yeah, I'm going to redistribute the connected and the local routes. Some metrics that we can set, not working with graceful restart or summary addresses. And then you get the overview here. So basically enabling OSPF on the VRF with process ID 10. So before I apply, just do a show run OSPF. You can see that there's one OSPF process, which is for the underlay. Other than that, nothing configured there. And so hit the apply button. You can see that it is in AFC. Let me just do a show run OSPF again. And you can see now that that process has been created and OSPF is running on the switch. It's not being enabled on the interface yet. So the other thing, you don't see any areas either, right? So you should have an area in the OSPF process. So you got the area in OSPF process 1, but not in the OSPF process 10 yet. So that's the next thing that we're gonna configure is the area. So once you have the router, you can click on areas. You can see the areas and then you can create the area. Go into actions, add, so that would be 8360 area 0. My area ID would be 0000. You can select the type, but it's like a standard type. We just have a peer-to-peer range there. Yeah, so for the ranges, we don't really have to provide any ranges here at this stage. Just create the area. And so that's your summary. And once I hit the apply button, that area should be created on the switch. So just go to that switch again, show running, and you can see that the area has been created on that OSPF process. Now once the area is configured, I can click on the three dots and select interfaces. And what I'm going to do now is enable OSPF on the Vlan interface, so Vlan 1200. You can see that here. It's a broadcast network. So I've configured broadcast on the other side. Yeah, so you can set some timers. I'll just leave them default. Also the authentication, you can set that. I haven't configured any authentication on the 8320 side, so I'll just leave that as well. And then the summary is pretty straightforward. It's just enabling that on the Vlan interface. So let me just go here, just do a show run interface Vlan 1200 and then apply. And you can see that the Ospf configuration is applied. Now let's see if we can get some Ospf routing information in from the 8320. So let's go to the VRF and go to the routing table. You can already see some external routes coming in, some type 2 routes, Ospf routes coming in via VLAN 1200. So let me just filter out on Ospf and the external ones, apply the filter. And so you can see that there is a default route coming in from 10.6.200.1, which is the 8320. So that's your default route. And there are some other prefixes also being advertised by the 8320. So that means that my adjacency, my Ospf adjacency is up and running, and I should get that routing information fed into the VRF. And that's all for now, folks. Thanks for watching again this video. And so thumbs up here. If you like the video, feedback always welcome. And I hope to see you soon on the next video where I will be creating the EVPN VXLAN overlay. So that's all the good stuff with layer 2 and distributed layer 3 in the overlay. So I hope to see you soon. Thanks and bye bye.